Hi everybody, so in this video I'm going to be talking about how to create a project in Altium and design a schematic and then convert that to a PCB design. So this is going to be aimed mostly towards solar cars since we use Altium Designer, but if you just want to learn the program, this might be a good. So the first thing you want to do on Altium is make sure you have a license and an account that you can sign into so that you actually can use the program. If you aren't signed in, you don't see a name or an account right here, you'll only be able to view files and change certain things. So if you have some type of school account or your school has it on lab computers, I would recommend logging in for that and using it. Otherwise, if you're in a club like Solar Car, contact someone on leadership to get that access. And so that's what I'm using right now. Iowa State had it and they removed it, I think, my sophomore year, which is really disappointing because it's a really nice software to use. But yeah, I do have Solar Car still for it. So first thing you're gonna want to do is create a project. So you can see if you go to File and New, you can create a schematic file, a PCB file, a CAM document, an output job file, or a component. And then you can also do some stuff with libraries. But we just want to make a project right now, which is going to encompass all of those different types of files. So I'll click New Project, and then it'll ask if it wants to be multi-board or PCB project. We just want it to be a PCB project for the project type. And I'll just name this Altium Tutorial since it won't actually be going into any Solar Car. And then you just pick a folder path. Everyone's done this before. I'm just put this under a certain little folder here. So I also already downloaded a pre-made library that we have in Solar Car, so I'll show how to parts and add that in. But there are some default libraries you can find online, and there's other ways to do that too. But I'll pick this folder to be the kind of root folder or the master folder for the project, and that's what we'll be referencing for everything going forward. So then you'll hit create, and then you will see that the project PCB folder is made here. So whenever you want to open the entire project and you go into this file path, you'll see here we have the Altium tutorial folder. So what you would want to do is just double click on the project PCB file and then you'll be able to access it. If you click the individual .schematic or .pcb files and open them in Altium, it'll only open that file and it won't reference everything that encompasses it in the project file. So this is kind of what you want to go to if you're opening it up from your folder directory. So you can see here we don't have any documents added yet. So the first thing that you want to do is probably add your library for your parts so you actually can build a schematic with it. So let's see. You can do add existing to project. And then I can go up to this parts library. And then I should be able to go here. And I think you can just drag and drop and get all of these. We're not going to go through parts here. But so now you can see I made this libraries folder, and they have the PCB library documents and the schematic library document. So a lot of PCB design softwares have it in a way where there is a schematic symbol to represent on a schematic like what a resistor looks like, where it might just be like those zigzags. But then for the PCB file, it's going to be what's called a footprint, which is normally some size rectangle that you'll actually solder the resistor to, and they're surface mounted through resistors, so it kind of varies on what the size of this could be. And if you're unsure of those, there's general practice sizing for those, like 0805, 1206, and so on, and you'll get a good example of these in here. And let me just open one of those up to show you. So we got resistors here, and then you'll be in the project file at the bottom left here, covering it up over. So you can see you're in the projects right now. If you go to schematic library after opening one of these schematic libraries, you actually could see all the parts that we have in the Solar Car parts library. So for example, these are schematic symbols. So you can see it's a very traditional resistor. We have the value and then the size. So this is a 1206 metric footprint. And then you also can see which PCB footprint is actually linked to it in the respective PCB library that we also have. And that was one part of building this library that I did. So if you have any questions, I'm around to ask for that. But you can also make sure that it's linked to a footprint by down here. So if you only imported the schematic symbols and you didn't see any footprints down here, you would know you imported something wrong or you only did one part of it. And you also can see, down here in the library, like you can see the schematic libraries have the .sch and the PCB libraries with the footprints have the .pcb. And yeah, so that's pretty much that. They're all linked. I know this works because I worked on it, but then you can save the project with Control S, and then once that star goes away, normally I just do a save all. You know that your work is saved, which is good because you don't want to lose work. But that's like every other document. So now we want to make a schematic. So I would recommend, and what you will have to do, is hit Add New to Project from right-clicking, and then do Schematic. And so you'll see now that a new folder is made called Source Document. So this is going to be the bread and butter of where you're going to be working in to design whatever PCB you want to do. So we can rename this and just call this, I don't know, Basic. And so then you can see it's saved here. Has this little reference right here, which, oh yeah, it just shows its file path. And so now we need to start working. I'm not going to go through and make a full circuit, but I'm just going to drag a couple different parts on, maybe link them up and show a few things just so you can see what happens. So you're probably wondering, okay, great. I made the schematic. How do I actually put parts on it? Well, since we already added these libraries over here, if you go to the right under this components panel here and you select it, you actually can select the different libraries for the schematic symbols and just pick and place them. It's really easy. And if you don't see this components library here, just go to this panel screen on bottom right, which I'm now blocking again, right down here, and you can select components or manufacturer part search. I'm going to be using components, and if you're in Solar Car, I'd recommend you do the same with this new library that we've been using. But you also can do manufacturer part search and look up a general part number, for example, like a resistor. This is a very useful tool just to get something that is the right symbol and the right footprint. You don't even have to use this exact part from DigiKey, but say you want a 0805 10K resistor with a 1% error rate. You can filter that through and pull one of those, and then there's like thousands of that exact part on DigiKey. So if that one's out of stock, it's not like you have to go find a library and get a new one for it. You can just find a substitute part on DigiKey and then order it, and then happy. But we're not going to go through this right now. I'm just going to show drag and dropping on this page. So I'll just kind of pull a little bit from each of these and just show different parts on the board. So capacitors and resistors, if they're surface mount, they are very similar, like footprints and sizes. So for example, capacitor, you care about the capacitance, the maximum voltage rating, and then the size. So this part right here, we can, you can see, you can expand this tab out and read about it. Stretch these out so you can see it's a 1 UF capacitor, max voltage at 50 volts, and it's a 1206 size. So say, cool, okay, maybe we want to filter a power line coming into the board, or maybe filter a signal going out. Cool. Now we can do that. We can get a couple other parts. We can get connectors. So we have a 4-pin, we'll do a 2-pin megafit connector. On Solar Car, these are very common to be used for 12 volts and ground going into the board and out. That's something we changed last year. So that'd be cool. Let's get a diode on there, maybe just filter something. We could probably do this. What did we use before? This, I think it was a PBS. Oh, it is not that part. That's a weird part. Keep actually opening parts. once you place it, you can... let's just do this one. These guys. So I guess I'm getting a little ahead of myself here. So to navigate kind of what you're doing on the schematics, if you left click and drag, you can select multiple parts, and then once they're highlighted, you can drag them around at the same time. It's very nice for editing the circuit. You can right click and you can place different parts or ports or wires or net labels, and we'll get to those things. That's probably the main thing here. You also can do a cross probe. This is really nice when you have both a schematic and a PCB, because you can select it and you can say, hey, this part, this diode right here, I want to see where that's at on the PCB. And you can go to the PCB page and it'll be highlighted. And if you ever need to clear a highlight or a filter, you can right click and do Shift C, which is clear filter. And you can do that without having to right click either. Talk about what's up here. So we can just kind of go through some of these. So you can do some of those basic movement tools. You also, I would recommend using Altium with a mouse. Like I said, you can left click and right click, but you can also hold down right click and then kind of drag around the schematic, and then you can press down on the scroll wheel and you can zoom in or out. If you're using a trackpad with this, it's an absolute nightmare. It's not worth it at all. I would really recommend just going to a lab computer if you're going to do that. But yeah, you can select objects by lassoing. Oh, this is good. I don't really use that. I just drag and drop. Place part. So this, you can hit this little yellow piece up here and it'll make the components page come up. It might also have the manufacturer part search if I didn't have the libraries open, but that's an easy way to find that if you don't have it, the panel selected down here, and you kind of forget. Control W is placing a wire. So like I said, you can click all the stuff up here, but there's shortcuts with it that are annotated whenever you hover over it. So placing a wire is just, you know, placing a trace or a wire that you would in a schematic. And so you can place them however you want, and you'll notice it's kind of on this grid, and you actually can make the adjusted grid lengths larger or smaller. I'd recommend having some type of snap lock grid on, and it will be on by default because it makes managing the circuits a lot easier. But then you can press escape, and then whatever, like the last few, whatever wires you double click between. So say I'll press once for left click, and then I'll press again, and then I'll press one more time, press escape, and then you have a wire. And then you could connect, you know, your diode, your capacitor for power filtering. You could connect it right here, and this could be like, let's say your 12-volt line, and then we could have the other line here like grounded, something like this. Yeah, so another thing that's really important and useful in Altium is the ports and all of the power symbols. So if you go up here, you'll see a ground power port. And so this is nice because it's a lot easier to read than just labeling a wire as ground. Because visually you can see, oh, hey, it's ground. So cool, you have ground. And if you right click the ground power port, you actually can get access to a couple other default power ports they have, involving a 12-volt, a positive 12-volt power port, a positive 5-volt power port, and B. This is really nice because, like I said, it makes it a lot more clear at what we're doing. So we can just make this top one, we'll make it 12 volts since we made this Zener diode. I think the breakdown on this TVS diode is 19.9 volts. So yeah, we'll make it 12 volts. If it goes past 20 volts, then this diode will break down, and then current will flow from 12 volts to ground, protect against voltage spikes. Signal harnesses, I have never used any of these, so I'm just going to ignore it. Sheet symbols, this is something that you can use if your schematics get really complicated. I know one project that uses it because I used to work on HeadNode. And I'll just, yeah, ignore all those errors. Those don't mean anything. Yeah, so this is kind of how sheet symbols are used. So what you do is that there is a main schematic page that kind of acts as an umbrella to cover other ones. If you want to see more on this, you can see my HeadNode video. But so you'll see that on every schematic page, whatever is coming out of this schematic page and into another, it either has an input or an output port right here. And so you can place the ports with the tag right by the sheet symbols. But so even if you only have those input and output ports, you're going to get a little underline red error because you don't have a main sheet page like this. And so what you can do is you can make a sheet symbol by right-clicking and hitting sheet symbol. And then you can say, like, what size it is, because you can see some of these don't even have ports in them. Some have a lot. It's really just making it look as clean as you can. It takes a bit of time. So for designator, you can name it whatever you want. And then for file name, you're going to name it whatever the schematic page is here. So, for example, for the connectors page, the designator name is connectors because it's easy to read. But the actual file page is connector_exp.schematic.doc. So yeah, and then you can see here we have both imports going in, pointing into the schematic page, and then we have outports going out and pointing out of the schematic page into another. So you can see that between these sheet symbols, PB start begins at logic interface, so it's a output from the interface page, and then it goes as an input into the connector page. And that is because some logic is handled in the board. And so this signal that's being sent to power board to say, hey, we're ready to turn the car on and get her going, will be sent from internally in the board on this logic page to the connectors page, where it'll actually be outputted as a 5-volt signal to power board. And so it's on the connectors page because there's a connector to go from one board in the car to another. And so, this is something like we've been cutting down a lot of parts on head node. You could argue you probably don't need this, but it's kind of a good way to explain it, because you might see like all this stuff and accidentally place a bunch of green stuff down and be like, what is this? Like, why does this matter? Well, this is how it can matter. But then once you place the sheet symbol, you can right click and then left click again to put a sheet entry. And so a sheet entry is pretty much just these little yellow tags you see. And so you can place one, and then you'll see here that it doesn't have an arrow either way. That's because I think it's marked as unspecified. Yes. And so you can mark it as either an input or an output, and you want to make sure that you stay consistent with your inputs and your outputs. And then you can also select the name of it. And so you would just want to make the name the same thing for both the input and the output. And so you can see here that it has this little red squiggly here, and you can see that it's upset at me because there's not a port name 35 and it's not defined. But if we were actually using it and you defined it, it's a good way to check to make sure that it's actually understanding going from one end to the other. Because if it doesn't understand that, then you're going to have an issue connecting traces on your PCB, and things might not connect, and it won't tell you that they're not connected because the schematic doesn't expect it to. And so that's something really important to consider. But so yeah, we have this here, and then let's place, let's just do like something. So we'll go to Schematic Library. Let's do a 1 mega ohm resistor that's an 0805 size. So it'll be a different size from a capacitor, and you can kind of see the scale difference. So we'll place him down, then we'll drag over with right click, and then we'll put it over here, and then we'll just call this net. We'll do this for an example. So I press Control W for the wire, double click, press escape. And so you can see here it's going to show an error. If you highlight over it, might show you why it's not happy. Probably just because it's connected to nothing. So it's saying, hey, why is this here? This is floating, so it's not going to pull any current. What's going on? And so we are just going to call this a label. And actually, I'm going to do one more thing as an example to show this. So what I'm going to do is I want to show the risk of ports. So you can see here we have a 12-volt power port. So I'm going to show an example of what happens when you get your power ports mixed up. You might know that VCC coming into the board is 12 volts, and you might mark it as 12 volts here. But Altium does not know that VCC and plus 12 are referencing the same thing because they are labeled something differently in the program. And so you'll see what happens when we import this to a PCB. This resistor here is not going to have a trace connected to the capacitor or the diode. And then similar to the power ports, you can do this with regular discrete or analog signals if it isn't directly like something that you want in here. And you can do that with net labels. And so net labels are under where the wire would be. So if you right click the little squiggles here where the wire normally is, you can select net label. And then a net label is used. You can call it anything. So we'll just call it, we'll just say button. not what we're doing, but it'll be easy to find when we're looking. So you can see here that this is showing red squigglies on both sides now instead of just the right side, because VCC is not referencing 12 volts like it was before, and there is not a corresponding net label for button. If we made another wire here, and then we also called it button, it should be happy with us. And so one thing you can do is, you see there's a drop down on the top right here. So if you hit the drop down, you actually can use a net label and do +12 or ground or VCC. It just won't have the fancy little symbol with it to tell that it's like a power port. But you can do it. But so let's just say we connect button. So it looks like it still does not like that because it doesn't go to anything. But you can see if we ground button here, it's happy. So we'll just keep it grounded here just to, show that. But yeah, so trying to think if there's much else to this. One thing you want to be careful with the net labels is making sure that it's actually connected to a point. So sometimes if you start editing things, you might remove the net label from the wire it's supposed to reference. Also, one handy tip with the power ports, whatever you set your power ports to for after your switching regulator or whatever power circuit you have, you're like, this is the standard 12 volts, this is the 5 volts, this is what we're going to use for, any capacitors that are going to be decoupling, anything going to our microcontroller, this or that. Always copy it from whatever you started with for the power ports instead of going up to the top and placing it, because they might get mixed up. And you can run a DRC, or if you're scrutinizing it in the PCB design, you will see it, but it's easy to miss that stuff. And then you order a board and you wait a couple weeks and you realize, oh, I gotta wait 3 more weeks for this project to get moving. But yeah, so with the net labels, if you normally click and hold the net label and then move it around, it should default to the wire, where it's referencing. Sometimes if you click and hold, you also can select the individual pieces. Sometimes if you double click, you can too. That's kind of finicky though. That's just kind of using the program. But yeah, so we got some work done here, so I can Control S and I'm going to save this. You also can add text. So let's say maybe you want to explain what you're doing, so I can add a little text thing and say, this is a circuit. Wow. You can change the font of it. You also can make these little text frames, and go like, this is a really cool circuit. Wow. And then you also can do these little notes, which are like sticky notes. I kind of like. I think you also can. It's an aesthetic thing. But yeah, that's good. Sometimes if you make changes, you want to explain to people, be like, hey, this might look really weird, but there's a reason why we're including it, because like the car won't turn on without it. But yeah, so that's kind of it with the schematic stuff. I think with the schematics, it'll get the most complex whenever you start adding more pages. Most of the starter projects or things you work on will probably begin with like 1 or 2. But the key is making sure whenever you update it on any page, make sure that if you're going to reference signals across both pages, use net labels and use power ports to reference it, and pay attention to these little red squiggly lines to see if that isn't referencing properly. But so let's say, cool, okay, we have our circuit done. What are we gonna do next? So what you want to do is create a PCB file and start designing your PCB. So let's see, I haven't done this in a while. I think if you do, let's see, if you do add new PCB to project, you can see here that PCB1.PCB.doc is created. And so if you then, selecting the PCB page, go to design and then import changes from Altium tutorial, which that covers changes from the whole PCB project and the schematic. We should, okay, yeah, so it's saying cannot locate document. That's because we haven't saved the PCB yet. So I'm just going to save it as PCB1.doc. Don't worry if it's a different name than the schematic. That's okay. Just make sure it's saved within the project root folder. So if we go to design and then update, it says, hey, there's 9 differences which can automatically be generated. That's pretty much a way to detect changes in wires and traces between them. So you can normally just say yes here. Oh, I forgot one thing to do. Okay, so you'll see here that these designator parts on each part have a question mark by them, and then the part number. And then if you click on the individual parts, you can get information about each of the parts. You say, oh, this is a TVS diode. Breakdown voltage is 16 volts or 19.9 volts. That'd be like that. But anyways, you need to give these designator parts a number because you're going to have more than one resistor in your circuit. You're probably going to have at least like 10 or 15 or probably more, just for everything. And so you need to know which resistor is what, because similar to having multiple resistors, they're probably not all going to be the same value. You might have some that are 10K, some that are 100K, some are 1 mega ohm. They might be different sizes. So it gets very convoluted, one, when you're ordering the board and getting parts for it, but also when you're trying to solder the board and debug it. So we use part designators. You'll see a trend where resistors start with R, capacitors C, diodes D. A lot of microcontrollers and logic gates start with like U. A lot of transistors start with Q. But you know, you'll kind of see that here, but your job is to give it a number. And so what you could do is double click on them and go, oh, I guess this is D1, or oh, this is C1. But Altium's nice and fancy. And so if you go to Tools, and then Annotation, and then Annotate Schematics quietly, it'll say, hey, we need to update 4 of these guys. Is that cool? And you're like, that's amazing. And then you'll see that it already does it. And you'll see that there's this little highlighted designator. That's what it changed from. And so if you save, it should go away. I think it might when you import it into the PCB. You also can see connectors are J. Forgot about that one. Trying to see if there's any other stuff in this tools. Probably not a ton. The annotation one's pretty good. If you just go, and you'll see here in Altium that every one of these headers has a little underline on a letter. And so that is because if you press that letter, it's a hotkey for it. So you can see tools starts with T and it's underlined here. If I go T, then I actually have that tools bar, but it showed up right where my mouse was. So I can go T and then A, because that's under annotation here. And then I can go Annotate Schematics quietly, which is under U. So T, A, U. It'll say, hey, no, you already did that, so we're good. But yeah, so memorizing little hotkeys like that are really nice. There's a couple like, you know, Control W, which are really nice. Control C, Control V are really nice. That's pretty standard. You can right click and then you can also get like, you can do place part and then you can go back to the components. I use some of these more than others. Once you normally have a full schematic, it's a lot easier to copy and paste components and then just give them a different designator by annotating quietly than it is to place them from the library, just to make sure that they are the same part and they're referencing the same footprint. But yeah, so now that that's designated, we're going to save that and then go back to design and then update or import changes from the project. So this tab is not fun sometimes. You need to be very careful at what you're selecting here. So this is called the engineering change order. I did not know that it was called that until I read it. So there are multiple actions that are going to be made when it imports these parts and this information from your schematic. The most important one that you want to make sure works is adding components. You can see here that our capacitor, diode, connector, and resistor are all checked here to be added. You want to make sure that this is checked here so that happens. You also want to make sure that the nets are added. You can see that the plus 12, the VCC, and the button nets are added. I'm a little unsure at why ground isn't, but that might just be a default one for some reason. But if not, that's something that might be worth checking. You know? It also adds a component class, which is called basic, and that is because that's the schematic we made. So there's a way in the PCB design to group certain parts in chunks like on the schematic pages just to kind of modulate it. but we don't need to worry about that. I would just make sure it's added. And then rooms are kind of the same way, where you can make a room where all the parts in the scope of the schematic. So what you want to do here is hit validate changes, and then it'll check to make sure that everything is referenced properly, it's saved right in your schematic, it's in the project folder. And then when you have green check marks there, you know you're good. And then you want to hit execute changes. Get green check marks here, you know you're happy. If you don't on some of them, that is okay, but you might have to do some digging to figure out why that didn't work. You know, it could be a thing of you didn't reference the schematic symbol with the proper footprint. So then it's like, hey, we see that on your schematic, you have a little zigzag for a resistor, but you don't actually have a 0805 resistor to reference it with. But yeah, then you can go over here. This is our awesome PCB. So you can see here that the room it makes it in is called basic. What you're going to do is click this and delete it. These, we don't want to use these probably for most projects. Every time you import, that's going to show up. Just remember to delete it. And so there's a little bit going on this page. This is probably where the bread and butter of Altium is going to be. But there's a lot of value in the schematic page too. But this is a lot more traditional what you would see in any like circuit design software. So here, oh man, okay, where do we unpack? So pretty much the black space here is what the PCB consists of. So you can drag, and then you say, look, our parts are on the PCB. If you press 3, you actually can get a 3D model of the PCB. You can see it is very boring and very open right now. Some general commands you can do. You can right click and hold to drag around. Middle mouse pressed, you can zoom in and out by moving your mouse up and down. Left click, you can drag and select things. So similar controls to the schematic page, just a different view and different things to edit. So one general practice that you'll see is you want to put connectors to your board on the edges of the board. And you're going to say, hey, this pseudo circuit is tiny. This default space in Altium is huge. So you actually can change the size of Altium's PCB. And you can do that under design and then board shape. And then you can do it by selecting define board cutout. But like I forgot to do, you need to define it with a certain shape first. So you'll notice at the bottom here, there are different layers. And so PCBs have multiple layers that you can use planes with, which act as giant areas that hold the same signal or power source or reference. So by default, Altium will create a 2-layer board. On Prism, we either have 2 or 4-layer boards depending on how complex they are and how many different signals they have to manage. You can do more than that too. The price goes up with the more layers you do, so at some point it can get redundant if you aren't doing a lot on the board, but sometimes it can help clean up a lot. And if you want to see that, I have some other videos on that too. So I'm gonna do is, normally in solar car we like to have a top layer for like our power, like 5 or 12 volts, and then the bottom layer for ground. I'm gonna call this we'll do 12 volts, and that was just by left clicking the red layer here, and then the bottom layer I'm gonna double click and call that ground. And so pretty much it's kind of interesting because right now you can see these parts are on the top layer of the board, but you actually can put their footprints on the bottom layer. And so to do that, you double click on the part, and then on layer here, it's pretty intuitive actually, then you select ground. And now you can see that these pads or these footprints at where the part's gonna go is actually on the bottom. And so if we press 3, you can see it's kind of on the bottom there to show you, but the part is not on the top anymore. Generally, if you can, you want to put all your parts on the top layer just so you don't have to have anything on the underside. It's just a risk of shorting with something, coming in contact with it. But if you need a little extra room on your board and you don't want to make it larger for size constraints, it's a really good option, especially for like experimental parts or something where you might not have it on after testing. But yeah, like I said, generally you want to put your connectors on the outside of the board. You can see here that the external part of the connector that's going out of the board is kind of on the top here, and you can see that with like this little mark right here. That's just something we have with our megafit connectors, or all those types of connectors. So normally you want to put the second yellow line on the edge of the board, something, zoom out, something like that. And so before we do that, I'm going to change the size of the board. So let's just say this will go right here. We'll just drag our other parts up here too. We know that there's not a lot going on. So some other stuff you can do to change the parts is you can select the part and then click and hold it. And if you press spacebar, you actually can rotate it. And so that's so you can get easier traces. So you can see here, oh man, like it wants 12 volts here, and then it wants you know, this ground or this button trace, I guess, since we shorted them together. Oh yeah, I guess we did. So it's called button now. Oh, that's why it didn't have the trace in it. Okay, yeah. Yeah, okay. So we're gonna actually connect this here, make a little more sense. So you save it, and then to make that change in here, since it still references button, you go to design, import changes, and then you'll see, hey, it wants to change this net name from button to ground. And then it'll also add the room, because it always does that. Validate, execute. You will see that these are all highlighted green now. That is because these parts are outside of the room that generates every time. You actually can, that's interesting. You'll see here if you move the part back in, and then if you regenerate it, maybe it's because it's outside the whole thing. Yeah, so now you can see the diode isn't highlighted. Another way you can get rid of this is deleting it. You can make it in your settings where it doesn't generate every time. If you want to stay sane, that's probably a good idea. But yeah. So now you can see this change from its name from button to ground. But so to change the size of the board, what you can do is you can use the line tool up here. And so you have to be careful. You have to be on mechanical 13 layer, which basically designates the body constraints or the size of the PCB. That's the specific layer of the mechanical stuff and defining it. So the line tools are not the best in Altium. Best thing I'd recommend is just kind of keep it straight. And then you can see here, something like this. You have to double click on it or else you'll get this weird 45-degree. You know what? Yeah, let's do a fun board. And then you want to make sure here when you reselect it, it has a little circle on here so that you know it's connected. You'll need to double click it too. And then what you can do, looks like an old SNES card. You can shift click, you hold shift and then you left click each of these. And then you go to design, board shape, define board cutout. Oh yeah. Then you can select, pretty much what you do is after defining the board cutout, yeah, it'll highlight it for you. And then, oh, no. Okay, I messed this up. Sorry. So you select these. I think you can do it that way too. I think I have before. You go to design, board shape, and then define board shape from selected objects. And now you'll see that that PCB size got way smaller here, but that's okay because we only have 4 parts. Yeah. So now what we'll do is define some planes. And before that, I kind of want to explain some stuff up here. So most of this stuff doesn't matter. You also can place components, but I would not recommend placing anything unless you imported it from your schematic to keep them consistent and to know you're designing something properly. If you want to create a trace, which is the equivalent to a wire connecting point A to point B, you can also hit Control W. Actually, yeah, Control W, left click. One general rule is you don't want to have a 90-degree cut. You always want to do at least 45. If you do something like this, it's just going to mess up your signal integrity. And if it's a very sensitive signal, like a software signal or something that, you know, might affect turning the car on or off easily, you don't want to have it up. Yeah. And that is in Altium called interactive routing. And so that's why you can kind of see, like, if you select something here, it'll kind of like auto pick it for you. I'm not clicking right now. It's just kind of, It's interactive, I guess. And you can press escape twice to get out of that. And apparently you're also gonna have quick routing, which it feels a little different, I guess. I don't know. But I stick with interactive normally. Quick routing doesn't look like it has a keybind to it. You also can create vias and pads. Vias are little holes that go through the board, and you can designate how big the copper is around them and how big the hole is. If you press 3 and you zoom in, you can now see that there's a hole in the board. And so you're thinking, why would you want to put holes in your board? You want to, keep it nice and full. Well, vias are kind of like the connecting roads in a city. The side streets go between the few main roads. So these can connect between every layer on the board so that you can have a power plane on the top, and then you can have 12 volts on the top, and you can have a ground plane on the bottom. And so the issue is these parts are on the top, so you can't make a trace and then just be like, oh, I'm gonna get ground here. It has to reference something, and so you can use this via as a highway to go down to the bottom layer and reference ground. And so I'll kind of show you how to do that. So let's see here. First thing you want to do is make a plane. So there's a couple useful commands with this that I'll show after you make one. So if you press T, which I think is, just tools, and then G, you'll go to polygon pores. And so this is how you can re-pour them. But I think if you go to polygon manager, here we go, polygon pour. So from the top here, you right click, you select polygon pour. So what you can do is you can select it, and you're gonna get this weird polygon selection thing. Just select the outline that you defined from the mechanical layer, and make sure you're selected on the top layer since we're defining the 12 volt plane. This. And then this one's another weird one where if you don't get it right on the line, it gets really weird. So you can see where it has that missing line to fill in the edge. Just make sure it's on the same one. And then double click it, hit escape. And now you're gonna see we have this ugly red mess that doesn't really go away. So you might be wondering, how do I get rid of this? If you press T, G, A, it'll regenerate it if you change the trace. If you press TG, TGH, it'll hide it. And then TGE will bring it back. And whenever you bring back all of your planes, it's going to have this weird highlight thing on it. So that's when you refresh it with TGA. Like I said, TGH will hide it. TGE will bring it back. TGA will re-pour the plane. So what we want to do is bring it back, and we want to double click this plane. And so you can see here, oh, it's on the 12 volt layer, but we haven't designated what net or what power line it's connected to. So we want to connect it to that plus 12 volt line. And you'll see here that it's going to want to regenerate again. So we press T, D, and then A, regenerate it. And now you can see that it's connected to this megafit connector through these lines here. And so you can see that on the top of the plane, it is actually connected to the copper that's going to be soldered onto the connector. And the main difference is you can see obviously that this ground one is not connected because it is on the ground net and not the 12 volt net. So now you want to do something similar at the bottom. So you want to select the ground, and you want to make sure that you're on the right layer, or else it won't be on the bottom. And then we're going to do the same thing. So we're going to do polygon pour, and we're going to select the outline of the board. It's okay if you go above the outline. I guess for an example, I can do square here. What'll happen is, okay, yeah, no, you have to set a board outline. Never mind. So I would recommend during these pours, doing the mechanical outline of the board. If you already made the lines for it, this is probably going to be a little easier. But yeah, there's a rule you can set in the project where the polygon pour will be within 10 mils of the outlined edge of the board, and so it's a nice way that you don't have to worry about that. So now that it's made, you want to hit escape out of that, TGA, make sure it's generated. You'll notice that it's blue instead of red now because we are on the bottom layer, or that blue layer. Then you select it, you'll see we have no net. Hit ground. Gonna want to regenerate. And then we're on the bottom. And so now you can see that the connector that's on the top of the board is now connected to ground on the bottom layer. And so if you hide them, sorry, you bring them back, you can see here that this is connected on the top, and then if you flip to the back of the board by right-clicking and then going, actually, I think if you go to View and then flip board, so it's just Control F. Oh geez, like a Windows intro. You can see here now that's on the bottom. So then you'll flip this around. It's nice crisp animation. You hit 3 again to get out, or you hit 2, sorry, to get out of that view. Regenerate these. You're on the second layer, so you're on the bottom. So we'll go to the top now. Whenever you're working and placing the traces, I would recommend to hide the planes by doing PGH, like that. And then you want to route everything. So what I would recommend is, even though these are all connected to ground, what you can do is you can just make vias. And so you'll see that you have the designators here, and you might be wondering, why are those yellow? So if you double click on this text here, like anything in Altium, you can see what layer it's actually on. And so it's on the top overlay layer, which is known as where the silkscreen goes. Silkscreen is pretty much wherever the text goes that goes over the conductive layers of the board, just to identify things. Normally you can like scratch it off, but if you put any text saying, hey, this is the board, this is who worked on it, you can create text like up here, and you'll see that the text will default on the first layer, which is kind of interesting because this is actually copper. Like you could conduct a trace through this, which is kind of interesting. I don't know if you could like ever do anything with that, but you don't want that if you're just trying to say your name, you know, like I'll put Jake here. You want to, instead of the 12-volt layer, you want to put top overlay if you want it on the top of the board. But it's funny because it's pretty cool because you also can do the bottom overlay right here. And then, you know, you can see it's not on the top, but it's on the bottom backwards. So then what you can do is you can select mirror, and this is a little tricky because it will look backwards when you're looking at the board on the top, but you actually can flip the board on without the 3D view like this, and then it's good. So it's not on the top. Back. But yeah, so you can do that. Turn off the mirror, we'll put it on top overlay again, flip the board around. So we'll save real quick. Very nice. So let's see here. So everything on the board on the top is connected with 12 volts already. It's a little weird because you'll see that this 12 and this plus 12 and this plus 12, you're thinking, oh, should that be connected? Well, if you press TGE, TGA, you can see that it's all connected through this entire conductive layer here. You can see that the, bring this down a little bit. So you can see here that the conductive layer for this plane is a little brighter green than this, so that's a good way. And it's like that when you get a board too, or well, when you get a board, it'll look kind of clear if you don't have the planes on it or not properly done. But in Altium, I hide it with a different color like this. And you can see, so since this is conductive and all on the same part, it'll go from 12 volts here, it'll go to here, and then to C1. And so this can get a little tricky, because what can happen is you can have a trace that goes like this, and it can completely cut your plane off. And so this is what we would call an island. These suck, and you can use vias to get around them, but you want to use good design practices to make your traces short, and so that they don't completely cut this off. Because you could say, oh, hey, you know, looking at this, these two pieces have 12 volts, but they aren't actually connected to the part that's getting 12 volts from outside the board. And so Altium's kind of smart with this. And so you can see here that now this is especially bad when you don't have the planes on, because you're designing this and you don't think about it. But you highlight and you're like, oh, that's kind of weird. Why are these connected over here on the right, but this one on the left here isn't? Well, go TGE, TGA, you can see that. And so something that's kind of fun is you can double click on the plane and you can hit remove dead copper and then hit TGE, oops, VGA. And so sometimes it won't do it. Dead copper will only be shown if you do something kind of like this, where it's like literally hold on. Make like a circle. No. Hold on. We're gonna do something. So if you just make a circle. Doesn't want to connect because that's okay. But yeah, so that's called an island. You want to avoid that. Very. But what you can do is you just want to pay attention to these highlights here. You also can run a design rule check or a DRC for that under tools and DRC. That's something I recommend at the end of the project. But yeah, so you do DGH to hide it. And so then you'll see, oh, well, I deleted this, but why is it still showing highlighted here? Well, that's because you did not regenerate your planes. And so you can see here on the hypothetical old plane, it still has that divide from the wire. So if you go T, G, and regenerate it by doing report all with A, now it's happy. So you don't really need to do any traces on the top. It's kind of nice. So just to show like how you can do Control W, and you want to select on this pad here, because this is the conductive part from the copper in the board that's going to go on the surface mount part. And so you can kind of see on the resistor here, this is the actual resistor. These gray tabs here will be able to be soldered onto, and then it'll go onto these pads from the PCB footprint, which will then connect to, and so you can see that actually probably better, whoops, on the back. So you want to make sure, since we're on the back, you can connect ground. So we'll go to ground, and we'll connect ground from here. Oh yeah, wait a minute. Okay, I need a via. So let's get a via up here. So one thing that's interesting is, did we ever set this to ground? Yeah, we did. So you'll be wondering, oh, you know, this piece has ground, why isn't it connected? So since this is kind of the start of the connector, it's reaching out to these parts because it knows that it's on the bottom layer, and the piece is on the top layer, but the ground plane is on the bottom, so it can't reach it like these 12-volt ones can. And so you can see here that most connectors you see are through hole, so they can go through every layer, every plane in the board, and get power from it. So through just soldering this connector on, it has access to both 12 volts and ground. And so that makes it really nice. And then you can just use vias, similar to this connector one, to pull power ground from the bottom all the way up to the top layer for the. So we'll just use one via as an example here. And so you can say, oh, these parts are kind of close. Maybe just want to use one via. You could just, it might be better for a risk of planes to use two. I kind of want to show an example of some traces. So you double click on it, and similar to all other parts, it might have a net assigned to it, and you want to pick ground. And then you'll see here, now that this identifies as ground, it will auto select to these two pieces instead of the connector. And so you want to make sure you're on the top layer, because these two parts are, because they're highlighted in red. You press Control W, and then click to them, just like that. Now there's no highlights to them. And so you also can see one more part over here has ground. And so since they're kind of far away, you know, you could have this work, but that's starting to cut up a lot of signals on the top of your board that's supposed to have 12 volts on it. So that's a little tricky. So what you can do is you can copy this and paste it. And then what you can do is you actually can drag the via into it, and then it'll turn into that net. And then you just press Control W, and boom. And so now you'll see that there's vias, and there's those little copper traces. And if you bring back the planes, you can see that the 12-volt plane actually connects to our 12-volt lines, as seen right here. And if you highlight it and shift it, you actually can see the different like connections. So you can see, oh, you know, where's this ground one go? You can highlight it, and it's really nice. But yeah, that's kind of it. I'm rambling. But yeah, obviously it gets a lot more complicated than this, but maybe, you know, you got stuck in a certain way. One other thing to make sure is make sure that your silk screen or your designators do not go out of the board like this. They go in. Then I'm going to save this, and then I'm going to bring back my... yeah, we can keep that there. So we can see we have both our planes generated, so you want to run a design rule check. All this stuff is fine. You can just hit, don't hit OK, hit run a DRC, and then it'll make a whole list of things that it thinks you did wrong. Some of these matter than others. So for example, hole size constraint, if you click on it, so normally what these have to do with is, if you click on it right here, it'll say, hey, the hole for this part is larger than what we allowed in the project. Well, the project one set it as a default, so you would just have to go into the project settings and say, hey, no, the default's larger. We expected this part to be this large, or you can just ignore it like I do. You don't want to ignore all of them, though, just to double check. But then you also can see there's 6 more issues with the silk to solder mask. This just has an issue to deal with where the silk screen is and how close the gap is between the silk screen layer and the actual copper trace layer. This is another Altium default. Normally, it's not an issue with different manufacturers like JLC PCB or other places. So, I've never really had issues with it. But yeah, so now you can say, cool, our DRC is good. Some that I would recommend watching out for are a short circuit constraint. You don't want something to probably be shorted. I don't normally see that one very often. The big ones are unrouted nets, so something that isn't actually routed to something. With constraint, that one can be kind of annoying. So you can see the settings where it's like, oh, the width constraint will be a min and a max of 10 mils, and I prefer to 10 mils. So you can set that larger or smaller if you want larger widths of traces to deal with power and high current power. But yeah. And then net antennas are sometimes ones that show up, and those are rule violations. The violations are the ones you want to fix. The warnings are like suggestions that sometimes pop up. You don't need to worry about those too much. But yeah, they're like, cool, save your PCB. Now you want to export it. So you are going to create a Gerber file. So what you want to do is you want to go to File, and you're going to export it twice. You want to go to Fabrication Outputs, and then hit Gerber Files. And then normally all of this on the general page is fine. Under Layers, what I like to do is do All Off, and then I want to select Used On. And you only want to do that for the plot layers. That's normally fine. And so you want to double check the basic ones. You want to make sure that you're outputting and exporting, the top overlay, the 12 volt, the top layer, the ground, the bottom layer for your copper planes, the bottom solder, the mechanical 1, the mechanical 13 layer. That's to make sure that it outline is cut properly by the manufacturer. That's good. You hit OK. And then you'll see this cam doc. So this is some of... we lost it. So this is what's actually sent to a manufacturer for them to... Oh my god, we lost it again. Is what's sent to a manufacturer to create. And so I don't know why it's going away from me, but normally what I like to do is save this. I mean, you can name it if you want. I like to save it and then update it in the project, just so if other people are checking the Gerber file or are looking for the output, they can see what I generated to see like where the issue came from, if it was a manufacturing error, if it was me being making a mistake, or exporting it wrong, yada yada. But then you'll notice on this file there is not everything we need on it. So sometimes you also have to make a drill file to make sure that the parts of the PCB actually get drilled out. And so what you can do is go to Fabrication Outputs and then do NC drill files. Normally I don't touch anything here. I just hit OK. You hit OK. And then this is a whole separate file just to show where it needs to drill through the board to make those vias or those holes. And so you can see here, this is the 2 for the connector. These are the 2 ground vias that we made. So you can also save that if you want to include it in your project. But then it's done. If you go back to your folder, I'd recommend saving everything just so everyone's on the same page. And you can go to Altium tutorial project. You can go to project outputs. And so this is going to have the design rule check you made. It's going to have all of the Gerber files. And so each of these files, these Camtastic files, is a different layer. I forget the name of like the top layer and the important ones, because sometimes you have to know it for layer order because they want to ask and confirm. But yeah, and then you also, I think the drill files are also in here. What you can do is you can right click this folder, you can hit send to, and you can zip it, and you can do Altium board order, and then you can go to a site like PCB. So you can go to this website, JLC PCB, and actually get a quote on it. And so what you can do is you can add this Gerber file that you just zipped up. That's my resume. Oops. Where did I have? I had this in here. Yes. So now you have that board order. You want to make sure you submit the zip file. What's really nice, because at least on JLC PCB, you can view the board just like this and be like, hey, that's what I designed, that's what I expected. And it's really nice because you can go to the Gerber viewer, you can see how much it costs. It costs $2 and then $20 for shipping, which is pretty typical. But yeah, that's kind of the process through and through. It's going to be a lot more complicated when you're working on an actual project, but I think that's kind of the bread and butter of it. So hopefully that answers questions. Yeah, so I don't know. If you have anything on Solar Car, like obviously feel free to reach out to me on Slack. And if you're just doing another project and you have questions, leave them in the comments. It's gonna help. But thank you. Bye.